check the ERP that assignment have been given to you, and the last date is 22nd, I guess. Please check. I have written all the things in the remark section, so please check. I'm sharing my screen. Okay. So last class we discussed about a method of joints, and today we'll discuss method of section. So is my screen is visible?
Yes, ma'am.
Okay, thank you. Please reply faster so that we can cover this part in this section. Otherwise, we have limited time for the meeting. So last class we discussed method of joints, and I have shared the PDF files also. Please go through that, and if you have any doubt, then let me know. We'll take some extra classes on that. Okay, regular classes we cannot do same thing again and again. So if you have any issues, please let me know. We'll take extra class for that section, method of join. So let's start with method of sections. So what is basically method of section? Suppose in the we have two analysis. We can do the we can find out the force member. What is the purpose of this method? We generally use this method to find the forces in these members, right? So we have one method of joints. So, but when the long trusses are often used to construct bridges, in bridges there are the length of the truss is very big, right? The method of joints requires that many joints be analyzed before we can determine the force in the middle part of the truss. Suppose you have been asked to find the force in this member. Okay, I'm annotating with pink color. It is visible. I'm annotating with pink color. It is visible. Now red color.
Visible.
Okay, okay. Suppose you have been asked to find the force in the member middle part. Suppose you have to find the force in this member. So if you go by method of joints, then you have to you have to start analyzing with each joint, right? You have to analyze the all the joints. Then by solving, you will come to this part. But with this method of section, you can directly cut a section on this part. You can cut a section on this part and you can analyze. Okay, so this is the shortcut, you can say shortcut method or fast method comparison to method of joints also. Okay, so in this method of section, a truss is divided into two parts by taking an imaginary cut through the truss. So suppose this is a truss given to you. You have been asked to find out the force in the member GC. Okay. So what you have to do, you have to take a cut section, considering that you are cutting the section so that it is cutting only three members, not more than that. Okay, the cut, what wherever you cut, suppose you are cutting here, you should cut always through those three members only. Okay, next you should also see that the member you are considering on, suppose you have been asked to find the forces in BC and GC. So you have to make sure that you cut the portion in such a way that these two members will come along with another some others members. Okay, suppose you have been asked to find out the force in EF member. So how can make you cut? You can make a cut like this, right? You can if you cut like this. So see here, five members are coming. One, two, three, four, five. So this cut will not be. Uh, it won't give you the answers. If you make cut in this way, such that it is getting the member in which we have to find the force along with two other members. That means you have to cut a section in such a way that it cuts maximum three members along with the member you need to find the forces. Got it? Since truss members are subject to only tensile or compressive forces, we have discussed earlier. Earlier we have assumed that a member is compression. Then we found out if we get positive answer, then it is in compression. So that means our assumption was correct. And if we get negative value, suppose we have assumed that the member is in compression, then after solving, if we get negative value, right? After solving, if we get negative value, then we see that our assumption was wrong. The member is in tension. Okay. So you can assume that if you assume that the member is in tension, so as positive, so you have to consider in that way. It's up to you. You consider whatever you make assumption, that will be positive, and along other sign will be negative. So since truss members are subject to only tensile or compressive force along their length, okay, the internal forces at the cut members will also be either tensile or compressive with the same magnitude. That means, see, if this is a member, it is at end points it is getting tensed, right? At end points it is experience tension. So if you, when you cut this member, the member will also internal forces will also be tensile. See, this is the whole member. I made a cut of this section. Then these are the internal stresses which is also are in tension. In the same way, if I have assumed, or if the member is in compression at the end points, when I make a cut, if you see the sections in here also, the member are is in compression, right? So that's how. Next, you have to use the equilibrium equations to find out the forces. So see, this is the figure. You have to decide how you need to cut the truss. Okay, this is based on where you need to determine forces and where the total number of unknowns does not exceed 3. So your total number of unknowns does not exceed 3. This means you have to cut in such a way that it cuts along through 3 members and it considers the member where you need to find the forces. Decide which side of the truss will be easier to work. Suppose this is the cut I have made. Okay, this is the cut I have made. Now you can decide whether you can find the you can start the analysis from this side or this side. Either one you can take. Okay, that will come into your visualization. Which part you take to analyze? You can take this part or you can take this part for the further analysis to find the forces in the member. Once you find, suppose I am starting with A and I have found out the forces in this member, my work is finished. Okay, finish. But if you do in method of joints, you have to start with each point, then you have to come to this point, then only you'll get. Okay. Determine which side of the truss. Okay. If required, determine the necessary support reactions by drawing the free body of the entire truss and applying E of E, that means equations of equilibrium. So if necessary, sometimes support reaction, if you see the figure, you will understand that this will be the support reactions. Sometimes you might not need to find, but most of the questions you need to find. So how to find? The same procedure we have used in the method of joints. You have to draw the free body diagram. You have to equate all the external loads, like summation of fx equals to 0 and f of y equal to 0, summation of movements equal to 0. Okay, so see, this is the truss. I have made a section A. I have cut the section A, and this is the free body diagram. Once towards the once in tension, once in compression side, this is the compression. All the members are considered in compression, and in this figure, all the members are considered in. This member is considered in tension. This member is considered in tension. This member is also considered in tension away from the joint. Drawing of a free body diagram of the selected part of the cut truss, we need to indicate the unknown forces at the cut members. Initially, we may assume all the members are in tension or compression, up to you. Upon solving, if the member is positive, suppose if I am assuming the member is in tension and I am getting the positive answer, then the member is in tension as per our assumption. If the answer is negative, the member must be in compression. Okay, suppose I'm assuming the member is in tension and I'm getting the positive answer. Suppose I'm assuming assuming member is in tension and getting positive answer, then tension as per our assumption. But if I'm assuming tension but getting negative answer, then the member is in compression. Got it? This part is clear. So please note that you can also assume forces to be in either tension or compression by inspection, as was doing in the figures above, or we have done, and apply the equation of equilibrium to find the forces. So see, this is the one trusses given to you. Till here it is clear. Please respond. Still here it is clear. What is the basic difference between method of joints and method of sections? Please respond. Okay. Only one response. What about others? Okay, okay, perfect. So see, loads are shown on the roof truss. So this is the roof truss given to us. They have been asked to find out the forces in members DE, DL and ML. I have been asked to find out the forces in the member DE, DL and ML, right? So what I did, I made a cut with pink line. Hope this is visible. This pink line. Okay. Take a cut through the members DE, DL and ML. Now work with the left part of the section. Which section you want to work? This part or right part? Which one? You have given support reaction. This is pin. This is roller support. Which part? Left or right? Work out with the left part of the section. You would like to work out with this part of the section or you will start with this part of the section? Response, response. This is an interaction class. Left part. Others? Why left? Right. Okay. This is the right part. This is the left part. Right. Okay. What about others? How many members are there? 40 students, only few are replying. What happened to others? I'm asking that this is the member given to us. Okay. This is your left part from the section. This is the section. This is the left part of the section. This is the right part of the section. So I'm asking from which section we should work out. Obviously, see, when I'm making a cut section, if we analyze this part, we'll get answer easily, right? If we analyze this, if we analyze from this part, our calculation will be more easy. Considering this part, we have to come like we have to start with we have to find the support reaction, then we have to find some forces, then I can come to here, right? So this part is more shorter. If I solve this part, then I'll get the members in this part and my work will be easy. Finish. If I come from this part, see, I have to find more for some force member in these members also, which is no need, means no, not required, because I have not been asked to find the members in these members now. But if I come from left side, if I find out some forces in these members, then I'll come to know the forces in this member. So this part will be more easy and it will be less time consuming. That's why I'm starting with left part. Hope this part is clear. Okay. So determine the support. Say support. I need to find the support reactions here. So this is a pin joint. So two supports will be one in vertical direction and one in horizontal direction, right? So this is the free body diagram of this left part. Okay, this is 6 meter, this is 3 meter. So this will be at is going slant. This is a visualization, and you can find out from the normal trigonometry also. This is 6 meter. This is 6 meter. See, this is 6 meter. This is 3 meter. This is 5 meter. This is 4 meter, and this 4 meter, 4 meter, 4 meter is distance is given to you. Okay. Okay. Now analyzing the entire truss to find out these reactions. So analyzing the entire truss, we get summation of fx equals to ax equals to 0. So if I see the whole figure, there is no x direction forces, only this ax. So it is nothing but equals to 0. Then the vertical support reactions, then summation of all the vertical forces. That means this one, ay. I have taken the symmetry part. That's why don't confuse with 36 Newton. I have taken this part, symmetry part. That's why I've taken the half of that. Okay. So So if you take all the summation of vertical forces, there will be one AY plus this, what is this IY, equals to all the forces. Summing up, how much it will be? We sum up all the vertical forces, how much it will be? 12 into 5 plus 6 into 2. It will be 72. Okay. AY plus IY, here one will be IY, right? Equals to 72. And as this is one equation. Then again you can find movement about IY. Movement about IY and 6, 6 force into displacement, 6 into this, 12 into this, that will be a time consuming. But if you see, the structure is in symmetry. So vertical load, whatever the load they are applying from the upward, this will be lifted by IY and this AY and IY equally. That means 72 divided by 2, that is 36. This part is clear or not? By symmetry, the vertical support reactions, that means IY plus IY, AY equals to IY equals to 36 kilonewtons. This part is clear. You can find out also. Summation of AY plus IY equals to this way. This part is clear. Please respond. There is no horizontal force, that's why AX equal to 0. But when you take summation of all the vertical forces in this direction, you will get AY plus IY equals to, summing up all the forces equals to 72. Then you can take one more equation as summation of movement about IY equals to 0. IY summation of movement IY equals to 0. That means you have to do force into displacement. So one force will be AY into this distance minus 6 into this distance, 12 into this distance, 12 into this distance, like this way. You will find out that ultimately you will find out that AY equals to IY equal to 36 kilonewtons. That means your AY is 36. Also your IY is also 36. Got it? Am I clear? Please respond. This part is clear or not? How we got 36? Please respond. Okay. So next is okay. So we have found out the support reactions. Okay. We have this vertical forces. Then we have found out this support. AX is 0. We have found out AY. Now let's move to find out the forces in the members. Here I am taking movement about D point. That means movement about this point, this D point. All the movement about this point equals to 0. So see this AY force into distance. How much? 4 plus 4. I'm taking this direction as positive and this direction as negative. So this AY and this D can move, it will give in this direction. So force into distance, how much? 4 into 4, that is 4 plus 4, 8. So minus 36 into 8 plus, again I have 6 which is at a distance of D from 8 meters. So this is in downward direction, so this will come in this direction, that's why it is positive. Force is 6, distance is 8 meters, plus again 12 is the force, distance is 4 meters, 12 plus 4, plus I have FML, that means force in FML, this direction. So this force into this direction is how much? 5 meter, I guess. Yes, 5 meters. So force into this direction, that means it will come in this direction. So this is positive. So plus 5 ml into 5. When you solve this, you'll get this answer. This part is clear? Movement about this point is clear? How we got FML? See this diagram. I'm explaining once again. See this diagram. See this diagram. Okay, this is the free body diagram. You have to find out the members in FML, right? FDL and FD. I've given the name as FDE. You have to find the forces in the member DE, DL and ML, right? So I have taken all the forces in negative, means all the members are in tension. That's why I have drawn away from the joint. This is the joint. This is the joint. I have shown the members in away from the joint. So I have assumed that the members are in tension. So this is your, I have considered FDE, FDL, FML. Okay. So you have to find the forces in these three members. So let's start with FML. Okay. How can we find FML? So if we take moment about D point, of all the forces, moment about D point, FML is at distance of 5 meter from D, right? So if I take a moment about D, I can find FML. So what will be the moment about D? One, I can take this force, 36, that is A. 36 into 4 plus 4, A. This force is how much at a distance from D? 4 plus 4, 8. So 36 into 8. Force, force, force into distance. So 36 into 8. 36 into 8. And I'm taking anti-clockwise as negative. So negative. Done. Next, for finding moment about D point, I can take this force. 6. How much it is distance from D? 4 plus 4. That is 8. So this force is coming in this direction. It is clockwise. So I'm taking clockwise as positive. So 6 is the force, 8 is the distance. Next, I can take 12, this force into distance, for finding the moment about D point. So 12 into, how much is the distance? 4 meter. 12 into 4. Done. Next, what force is acting at D point? So this FML can be acted on this D point. So this force, again this is in clockwise direction. This will come in clockwise direction from D distance. So FML into 5 meters equals to 0. When you solve this, you will get the FML value. Now it is clear. Now it is clear. Please respond. What about others? Please go through videos. You get plenty of videos in YouTube. Okay. Then after going through some videos, if you don't understand, then I'll surely take extra class. Okay. So next, what we have, we can take summation of all movements about L. That means this point. That means L. Summation of all movements. I can take summation of force in x direction and y direction. I can find that way also. But now for point L, I'm not getting any. I'm not able to find summation of x and y. See, at this for FDL, we'll understand what equations you have to use when you solve the more and more numericals. So next we have summation of all the movements about L equals to 0. So this is your L point. This is your L point. Where is your L point? This is your L point, right? You have to find summation of all the movements about this point as 0, right? So consider when you find a movement about some point, consider it as a beam. Okay. So in this beam, one force is acting this 36. You have to find movement about L point, and in that beam, first force is your 36. My voice is clear? Hello? My voice is clear? Hello? Okay, okay. So, consider it as beam. Okay. So you have to find all the moments about L. Let me know if my voice is not clear. Okay. So all the moments about L should be zero. So one force is 36 kilonewton, which is at a distance of 4 plus 4 plus 4. That means 12. And it is an anti-clockwise. That's why 36 into 12. Anti-clockwise, that's why minus. Plus, what is the next force? 6, which is also at a distance of 12 meter from the L. So 6 into 12. Next, I have another force, this 12 meter. This 12 meter, which is also at a distance of 8 meter. So 12 into 8. Again, this 12 is at a distance of 4 meter. So 12 into 4. Okay. Do one thing, all of you write your roll number in the chat box. Please write your roll number in the chat box. Hope you all have written your roll numbers. Okay. I'll do one thing. I'll share this PPT with you. I'll share this PPT, and if possible, I'll make a video and surely share with you.